do these last few examples here. So if you guys could flip back to the notes, we still only have a few more examples. So give the ordered pair for each angle of rotation. Now if you look at these, you're going to realize, guys, heads up, please focus on this. You guys are going to realize that these angles, I don't believe any of them are special angles. You might think they kind of look like it, or they might be close, but they're not. Bella, your head's got to be up, please. So I want to remind you, though, that our coordinate point is basically what they're doing here is they're asking for the cosine and then the sine. Now this is going to be approximate because these numbers are not going to be nice. They're going to be long decimals, so it's all about a couple decimal places. Now 195 degrees. Kind of quickly sketching this. What's our reference angle here? 15. It's 15. Is that a special right triangle? I'm not going to like all of a sudden show you a bunch of new special right triangles. There is not a special right triangle with a 15-degree angle. So what we're going to do instead is we don't even need to really worry about that. We don't need to set this up in any kind of certain way. We're basically going to figure out what the inverse cosine is of each of these and what the inverse sine is. They want the ordered pair. So you can grab your calculator. And you're going to do inverse cosine of 195. Now again, not inverse cosine, just cosine of 195, sorry. Cosine of 195. Now, you should get an answer something like negative 1 point, or negative 0.1? 0.9, sorry, yeah, negative. So it's almost negative 1, right? So let's go 9, 7. Does it make sense that the cosine should be negative?
Yes.
Yes, because we're going down, so that makes sense. Then we're doing the sine of that. That's also negative. Now, does it make sense that the cosine should be bigger than the sine? Think about this a little bit. Why is the cosine bigger than the sine? Yeah, so saying the adjacent's larger than, so it's basically saying it's going over further than it's going down. And if this is a 15-degree angle, that kind of makes sense, right? You should be going over more than you're going down in order for that ramp to not be so big, if you think of it that way. So it makes sense that these numbers, like I know they're small numbers and kind of strange numbers, but that's okay. Like we're good with that. So that's all they're asking for. They want that ordered pair. So 107. If you like drawing it, you can. Otherwise, you're essentially just figuring this out each time. So you're just doing cosine of 107. Now this time sine's going to be positive, and that makes sense because 107 should be in just that second quadrant. Did that work out for you guys? So these aren't so bad. Just kind of getting that coordinate system idea that cosine and sine, that's all they're asking for there. Now negative 208 seems like that should be weird. It's not really. Negative 280, sorry. So this is 270, so we're up here somewhere. We're in that first quadrant, so anticipating they're both going to be positive. Wait. when I did that though. Oh no, I did 208 again, so I said it and wrote it in my calculator wrong. 280. So 0.17, and again, my adjacent's a really short little side there. And my cosine, or my sine, is a lot longer because it's a really tall, skinny triangle. All right, those ones aren't so bad, I don't think. All right, last one. It said give two angles that could work for theta if sine of theta equals 0.743. All right. If you just put this in your calculator, you could find one of the answers. Because if I want to figure out what theta is, how would I solve this? Inverse sine. So I could do that right now. So I could do inverse sine of this, and I'm forgetting to record. Sorry.